Hello my students, today we are going to talk about the physical and chemical changes. We will continue to this lesson, and if you want to follow me from your book, please open Module H Unit 1 Lesson 3, and pages between 40 and 44 will help you for understanding today's lesson. We are going to talk about the science of chemical change. How can we tell a chemical change has happened? First, I want to remind you what is chemical change and what is physical change. Physical changes are the changes that are not changing the identity of matter, but as a result of chemical change we can understand that the identity of matter changed and a new substance formed. So we gave some examples like burning and rusting are signs of chemical change, because as a result of burning we can say that the identity of matter is changed. But in chemical changes we can keep the identity of the substance. For example, just cutting a paper will not change the identity of the paper. The paper will still be a paper, but burning a paper will change the identity of the paper. Or change of state, melting, freezing, evaporation or condensation will not change the identity of matter. Water will still be water, and we can reverse this process back as a result of change of state. But in chemical changes we can't reverse the process, and we can't have the same substance at the beginning of this change. There is a chemical reaction happening in chemical changes. If you want to understand what are the things that we call as chemical change, you can look for these signs. Formation of gas, for example, is the first thing that we can look for at the chemical change. If you are seeing that there is a gas formation like fizzing, bubbling or foaming, these are the signs that a gas has been made during a chemical change. But don't forget, boiling will also produce some gas bubbles. Boiling water, for example, you will see some gas bubbles, but this is a physical change. But in here, like an effervescent tablet, or if you are seeing some gas bubbles as a result of mixing of vinegar and baking soda, so these are the just signs of a chemical reaction. What else? If you are observing a change in odor, what is odor? Odor is the smell. If there is a new odor is happening, for example, when you bake something, if you are feeling there is a new odor, you can say that this is a change. This is a chemical change. For example, when something is spoiled, when a food is spoiled, spoiled milk, it will smell different than fresh milk, because new substances formed over time, and then we can understand there is a chemical change. Or any type of spoiled food basically will smell different than a fresh food, like even the meals that you are keeping in refrigerator. In time you will see the odor of them will change, and this is a sign of chemical change. Or color. A change in color can also be a sign of chemical change. So, for example, these bananas, when they get ripened, so the peel undergoes a chemical change, and that make it turn them brown. Or light or sound. Production of light or sound can also be a sign of chemical change. So a chemical change can give off energy, and this energy might be produced in the form of light or sound. So like the fireworks, After fireworks popped out, you will see the color change and you will hear the sound. So these are the signs of a chemical reaction, and chemical reaction obviously will end up with a chemical change. Or this energy will produced in the form of heat. Some chemical changes, especially burning, will give off thermal energy. So, for example, when you open your stove, you are basically burning methane gas, natural gas, inside the system, and when they burned, you will see the bright blue flame. So this is a sign of chemical change, because you are producing heat as a result of this chemical change. Burning will actually result of this thermal energy, production of thermal energy. Or precipitation. Sometimes new solids can form during chemical change. For example, when we mix these two substances, both of them are looking transparent, but when they mix together, we are seeing this yellow substance, yellow solid is formed. So it is a result of a chemical reaction, and that we can understand there is a chemical change. So these are the basic signs of what we call as chemical change. Also, we can revise them from here quickly. Odors, like we said, when you bake something, when something is spoiled, the smell can be changed, so it can be a sign of a chemical change. Production of gas is an evidence of a chemical change most of the time, but remember, boiling will be physical change. It can also produce gas bubbles, but it is not a chemical change, don't forget. What else we have? The formation of a precipitate can indicate a chemical change. Precipitate is the solid that is happening as a result of a chemical reaction. Energy that change from one form to another, like light or sound happening as a result of a chemical reaction, like the fireworks. It is also a chemical change. And change in temperature and color also can be signs of chemical change. For chemical changes, please remember, these are the things that are just the signs, okay? For these signs, these are the things that just the signs for chemical change. But we can say that if there is an odor change, that 100% that is a chemical change, or if there is a color change, there is 100% chemical change. You can be just sure that if you are observing two or more of these signs, you are probably, most likely, facing with a chemical change. So for the remaining of this lesson, we will focus on something called as conservation of mass. So what is conservation of mass? It is saying that in ordinary chemical and physical changes, mass will not be created or destroyed. It will only transform into different substances. What does it mean? It is saying that we can't change the mass of the substances as a result of physical or chemical change. The total mass of the substances at the beginning should be equal to the total mass of the end products. Even though it is physical or chemical change, we should preserve the total mass at the beginning with the mass at the end. Okay? How it is happening? Let's see closer. For example, let's say there is a change of state. Change of state is a physical change. For example, this metal has a melting point close to room temperature. It can melt in your hand. So when substances melt or evaporate because of change of state, it is a physical change. They may appear to lose mass, but if you measure the mass at the beginning of melting, and if you measure the mass as a result of melting, you will see mass really doesn't change at all. Or if you measure the mass of an ice cube, and then if you measure the mass of the liquid water when that ice cube melted, you will see these two masses are equal, because change of state will not lose the any material, any matter. Okay, it will just change the type of state. This is an example for physical changes, but also for chemical changes. It is true. So as a result of chemical reaction, also mass will be conserved. For example, this photo is showing us the reactants before they go into reaction. Okay? And when we calculate their mass, which is over here, we will find that this mass will be equal to the mass after chemical change, after chemical reaction. After the chemical reaction, there is a now we have this product and we have the same mass. Okay, as a result of all chemical changes, we are observing the same mass. And also sometimes what we said, that chemical changes can produce gas. So if we produce gas, even though the gas will just evaporate into the air, if we are able to hold the gas and also measure its mass, we will understand that mass of the products will be equal to the mass of the reactants. Okay? Let's see another example related with this conservation of mass. In your book, if you open the pages that I showed you at the beginning of the lesson, I guess page 42 or 43, you will see this explanation about conservation of mass. So in physical changes, we are not changing the identity of matter. We are just changing the shape, sometimes color. Okay, so here we have a toy. We are just changing the parts of the toy, but we are keeping the same materials. The identity didn't change, and also the amount of matter didn't change. What is the mass? The amount of matter inside a substance, and it didn't change. So that's why we can say that all physical changes follow the conservation of mass. So what about chemical changes? Here we have another example with vinegar and baking soda. This is a really simple experiment and also safe if you want to do it by yourself at home. So we will just provide a closed environment for this experiment. We will put this baking soda into vinegar, and we will close the cap with this balloon, and we will see that it will preserve the total mass. So as a result of this chemical reaction, the balloon will get inflated. So the gas produced as a result of this reaction will fill inside this balloon, and it will blow the balloon up. And mass of these starting material, vinegar and baking soda, will be equal to the mass of these end material. Okay, we have a different type of solution here now, and also we have this carbon dioxide gas here. So please try it at your home. It is really simple. You can try it by using these balloon vinegar and baking soda, or you can just mix vinegar and baking soda inside a sealed bag so that you can see the gas exchange also. And so if the balloon can't catch this carbon dioxide gas, the gas will seem to disappear. But now that because we can catch the carbon dioxide inside the balloon, we can understand the conservation of mass. You will see this, how important this conservation of mass is when you study the chemical reactions in the upcoming years. So this is a really useful law for us to understand the behavior of the chemical reactions, chemical changes. We have a question here about the science of chemical change. Let's try to solve it together. It is asking for us the signs of the chemical change which are present when bread is baked. So, can we observe change in odor as a result of baking a bread? Of course we can. We can see the odor is completely changing before and after baking a bread. So, production of gas. This is the tricky one because we can't observe the production of gas, but we can see the small pores inside the bread, right? When you are eating, when you are cutting the bread, you will probably see some small pores. This is the sign of production of gas inside this bread while it is baking. And that's why the bread is getting bigger during baking, after baking. Okay? There is a production of gas, obviously. Is there a change in color? There's an obvious change in color because before we are baking, we know that the bread is white, but now it has brown or reddish color. So it can be also a sign of a chemical change. Production of thermal energy. We are using the effect of heat, but we are not burning the bread, and we can't say that there is a production of thermal energy. That's why I will not click on this answer. So let's check our answers. So all of these three are correct answers for our questions, but the production of thermal energy will not be present when the chemical change happening with the bread. Maybe in other chemical changes we can observe the production of thermal energy. But since we are observing these three, we can say that there is a chemical change in the bread. Okay? One may not be enough every time to understand there is a chemical change. We finished this lesson. Let's revise what we learned until now. Matter doesn't change the identity during physical change. The identity will be changed during a chemical change. New substances are formed during a chemical change. Different forms of evidence can show that a chemical change might be happening. What are these different forms of evidence? Change in odor, change in color, temperature, the production of thermal energy, production of gas, and change in production of light or sound. Okay, these can be the signs for chemical change. And mass is always conserved during ordinary physical and chemical changes. Okay, mass will always conserve. Don't forget. If you have any questions, please open Module H, Unit 1, Lesson 3 to revise all the subjects related with physical and chemical change. Today's session was related with pages between 40 and 44. But if you want to revise all the things related with physical and chemical changes, you can go look for Module H, Unit 1, Lesson 3. Thank you for listening. See you in the next session.